Okay, so what I want to talk to you guys about right now is mathematical or recursive subdivision. Sounds fancy, right? It's not. You guys probably did some of it when you guys were just that tall, 5 years old. So if I have a surface or an object, right, and for right now I'm going to go ahead and begin in 2 dimensions, and we can also talk about it in 3 dimensions, right? If I was to find the midpoint of this, let me just say that this is a person, right? Building. So if I was to find the midpoint halfway between here and here, and I was to draw a light line there, let's say it's about right here. I've just sort of visually divided that facade in half, right? Yes? Okay. So if I put a door here, and the same distance over, I put a door here, and let's say I put a window here, and I put a window here, you guys would say that that is symmetrical, correct? It's the same on one half as it is the other. And that's the part that I warned you guys about, that when you guys were 5 years old, you guys had already mastered symmetry. And that as such, if you're in college now, you might see if there's other things, right, that can create a greater level of sort of visual interest. Okay? This is actually very kind of really basic, right? So let's erase that right now. Erase all of these. And so I'm going to write in 1/2 and 1/2 here. So I've subdivided that elevation into 2 parts. Now, what if I further subdivide the halves into more parts? So what if I take this half, and instead of dividing it into a half, now I take it and I split it into 3 equal pieces. Okay? So I took the half and broke it into thirds. So let me kind of show you what I mean by that. This is the half, right? And then these are 1/3, 1/3, 1/3, 1/3. Correct? Now, I can still create something that is symmetrical there, right? Like, for example, if I put a door in the middle, and I put a window next to it in the middle of that bay, and a window next to it in that bay, I have, that is symmetrical, correct? But what if I take this one over here, and instead of dividing it into thirds, I take this one and I divide this one into half. So I divided the whole thing into half, and then I took this one and divided it into thirds. Now I'm taking that side, and I'm going to divide it in half. Right? And then instead of duplicating what I did here, I put in a large glass window here, and a large glass window here. Is there symmetry there?
Yes.
There is, but is the elevation symmetrical?
No.
It isn't. So it's highly organized. It was a very mathematical, rational thing. Take the big rectangle, cut it in half. Then take the 2 squares that are left, take this one and cut it into thirds, take this one and cut it into half, and use that to organize the shapes that I need to put there. Does that make sense? So sometimes, however, it doesn't need to be that you are placing an object in the middle of a spacing. Sometimes you're using the spacing to create the edge of an object. So for example, we did a bunch of corner cutouts, correct? Like this. So what if over here I don't create this, and I don't create this, but I instead use that line to create the edge of my porch, my cutout. So you can use the lines of subdivision to do multiple things. That could have been half. We could have also split it into thirds. So I could have said, all right, I'm going to split the whole thing in half, split this one into thirds, split that one into thirds. I'm going to do this on this side, and then do something different on the other side. I've created an asymmetrical composition, even though it has a highly organized sort of subdivided or recursively subdivided structure hidden in it. Does that make sense? And what I can say to you is that using something that creates asymmetry but has order to it is going to create something that is much more visually stimulating than if you just always do symmetry. Okay? So that's just an important sort of feature that I want you to be aware of. How many minutes am I at?
6 minutes.
I'm at 6? Okay. So when you get to your boxes, right? Your boxes are 30 feet by 30 feet by 30 feet. So what happens when we divide 30 feet into thirds? What do we get? 10. Oh. So if I divide this face into 10, into 10, and 10, I got 30, right? Yes? So, all right. So that's one way to go. If we divide it in half, what do we get? 15. If we divide it into fourths, what do we get? 7 1/2 and 7 1/2 is 15, and 7 1/2 and 7 1/2 is 15, that's 30. Okay? So this notion of subdivision into halves, thirds, fourths, right? Those three are really common. Sometimes people go further and subdivide into fifths or sixths, right? After a while, it starts to create compounding of what you did before. Like, for example, if I take half and half and I go third and third, I might as well have done thirds all the way across. Okay? But the notion of division into halves, thirds, and fourths to decide where to put something or where to stop something is a very, very important sort of way of going beyond the simple knee-jerk reaction of balanced symmetry. Okay? But it still holds a very strong organization. And those dimensions can be done both this way as well as that way, or they can be done just in one direction. Okay? A different way to decide on where the edges of something might be would be to use a module. And so, for example, I don't know if any of you noticed, but the porch and the floor of your building has to be how far up off the ground? 3 feet. You all noticed that. Good. So what is 3 plus 3 plus 3 plus 3? 10 times? 30. So if we took this facade or this elevation and this way we split it into half and then half again, and then I went 10, 10, 10, 10, 10, 10, 10. I mean 3, 3, 3, 3, 3, 10 times, I would end up with 30, right? And likewise, I could do the same thing here. Okay? So those are two things that I want you to be aware of. One of them is called subdivision, and the other one is called a repetitive module. Okay? You can also think of a repetitive module as kind of a grid. Any questions about that? Stop the video.